Our course, CPE 211, Data Structures and Algorithms Analysis, covers the topics of linear data structures such as arrays, stacks, queues, sequential list, and nonlinear data structures such as linked list, trees, and graphs. We would also discuss operations on these structures using algorithms such as insertion, deletion, and search traversals. Last school year, you have taken up programming courses in C and Java programming languages. And recall that we view programming as a problem-solving process, which involves first identifying the problem or understanding clearly what the problem is about. Because if you don't clearly understand the programming problem, then most likely you cannot come up with a correct solution to that problem. So you need to understand clearly what the problem is all about, what it requires. Second, once you understand the problem, we then identify what are the input data and output data needed. Like for example, if that program is to compute the area of a circle, then you can identify that the needed input data is the radius of the circle and the needed output data is the area of a circle whose radius is the input radius data. Third, we then identify what are the variables needed to represent those input data, computed data, and output data. So again, if the problem is about computing the area of a circle, then we can decide the needed data are radius and area. Then we also decide to declare variables with the name radius to hold the input radius data, variable area to hold the computed area value. After that, we then start to construct the flowchart or write the algorithm which describes the whole process of solving the problem from the first step to the last step. So programming as a problem-solving process involves these two equally important aspects. First, selecting the appropriate data structure to use in the program in such a way that the program's data are stored in the most efficient way so that the program can easily access, manipulate, or perform necessary operations on the data for the goal of obtaining the desired result or output data. And recall that I mentioned a while ago the 4 specific steps programmers do when programming. And these 4 specific steps are: first, identify the problem or clearly understand the problem. Second, identify needed data. And these data are the input data, the computed data, and the output data. And then the third step is identify needed variables or data structures that would represent those data of the program. So the second and the third steps all point to the first aspect, okay? So it is under selecting what data structure to use. So this refers to how data are used by the algorithm or program. And it involves, as mentioned already, the identifying of the correct input data needed to be processed. And for what purpose? In order to obtain the desired result or the desired output data. The second is designing the best or most appropriate algorithm to solve the given problem. And for this matter, it is the fourth step that falls under this aspect. Okay? Now, remember, when we write a program, say for example, to compute the area of a circle given its radius, then under step 2 and step 3, what are the input data, computed data, or output data needed for that particular problem? You would of course agree that the needed input data to that particular problem is the radius, right? and the computed or the output data is the area. And so what we're going to do is to declare these two variables. Okay, so if this is a C program, you would write void main, and then the main block of the program would involve first the declaration of the variables. Say you choose float as the data type, you would say float radius, comma, area. Okay, so this is your simple data structure involving only two atomic variables. And then what follows next would be the set of statements to be executed. And this set of statements describes the underlying algorithm of the process of computing for the area given this radius. So again, a program has two aspects: the data structure used in the program, and second, the underlying algorithm of the program's process in solving the problem.